Today we will see exploit writing by exploiting a target Windows application using buffer overflow. Before we do that, let us get a brief idea about exploit and buffer overflow attack. Exploit. It's a set of code or command used to compromise target application by using technique like buffer overflow. So what is buffer overflow? In buffer overflow attack, attacker sends excessive data to target program or process memory buffer, which overflows or overwrites the adjacent memory space, where the attacker can inject his own code and executes it. Let us understand it with the following diagram. This is the memory layout used by the process running on the target system to store a temporary data. Here we can see that it is arranged from higher address to lower address and divided into different segments. Dash segment contains the compiled data, whereas data segment and VSS segment used to store the global and static data. Heap stores the dynamic allocated data, whereas the stack stores the local variable. Here we can see that the stack grows downward and heap grows upward. So whenever the process takes a input from a user in the form of command or text, it is stored in stack and heap, and for that a space is allocated in the form of buffer. So you can see that the buffer overflow attack can happen in the stack as well as in the heap, but here we will be focusing on the stack based overflow. Let's say this is the stack space used by the target process. Now one of the functions in the target process will add its value in the stack, like local variables, some arguments and some parameters. Now this function calls a subroutine. So here the processor adds a return address. It's also called extensible instruction pointer. It points to the next instruction of the function. Next, the processor adds a frame pointer. It's also called extensible base pointer, which acts as a base reference for other frames. Now here the subroutines adds a local variable and allocates some space for the user input, which is called as a buffer. Now when the user enters some command or some text, it will be added to the buffer. Now what happens when the user input is more than the buffer? So when user enters data which is more than the buffer size, then it will overwrite or overflow to the adjacent memory space and overwrites it. Now when the return address is overwritten, it will point to the unknown address and the application will crash. So next, the attacker will find the exact location of this return address. Then it will inject its own shellcode for getting the reverse connection. Now it will change the return address to the ESP, that is the jump ESP command. It will point to the stack pointer, which is the next address after the return address. Now it might be possible that it will not point exactly to the start of our shellcode. In that case, the attacker adds some no ops. These are called no operators. It means it will not do anything and the stack pointer can slide to our shellcode and our shellcode can execute, then the attacker will get the connection to the target system. So let us see our practical. For the lab setup, we are using VMware. In this we are running Kali and Windows. In Windows we have installed an application called CloudMe. So we're going to exploit this application by using buffer overflow. It is running on port 8888. To see how this application is using memory at the back end, we're going to use Immunity Debugger. So after starting it, go to File, Attach, and here we can select CloudMe. Now in this interface, here we have register. This is stack, this is the memory dump, and here we have the commands. Now if you see in the register, here we have EIP, that is the instruction pointer, that is the return address, and this is the EBP, that is the extensible base pointer or frame pointer. If you go down, here we have the stack. Now when we perform the buffer overflow, this will be overwritten by our data, as well as this EIP and EBP will also be overwritten. So let us do that. For this, we're going to write our exploit. Before we write our exploit, let us check the IP address of this system because we're going to need it. So this is the IP address of this system. Now let's go back to Kali. Now here we're going to write exploit by using Python. So first we're going to import socket module to create a socket. Then we create a socket object. Next we're going to make the connection to the target application. And the port 8888. Now we send some data. So in data, let us send character A. So we send character A 1000 times to see if we are able to fill up the buffer. Now we execute this by using Python. Our file name is exploit.py. So before we run it, we need to start the immunity debugger. So here at the top we have the start button. You can start it. So here it is showing that it's running. Now go back to Kali. Now we can run this. So if we go back to immunity debugger, here we can see that no change. Now let us increase the size of our data. Let us send 1500 times. We run it again. Now here we can see that the application is crashed. Here no more commands, and here we can see that the stack is overwritten. Let me scale it. Yeah, here we can see that our EIP is overwritten with 41, that is hexadecimal of A, as well as EPP is overwritten with 4141. Now if you go down, you can see that our stack is overwritten with A. So it means we are able to perform the buffer overflow on the target application. Now we need to find the exact location of this EIP. So for this we have to send some pattern of data instead of sending this multiple A. So to create a pattern, we have a script here. We can find that script by using locate. So this is the script that we're going to use. Now here we give the length of our pattern. So you want to create 1500. So this is the pattern. Let us copy it. Now instead of sending this, we will send that pattern. So let us clear this. Now before we run this, let us restart it. Now we can run it. So let's go back to Windows. Yeah, here we have to start this. Make sure that it is running. So when you use the exploit. So now here we can see that the EIP is written, overwritten with this value. Yeah, here we can see that this is the value that it is overwritten with. So to find the offset value, we can use the same script. Here there is another script called offset. Now let us see. So here the offset value is 1036. It means after sending 1036 characters we are able to overwrite the EIP. So now let us modify our script. Let us remove this pattern. Now we will send 1036 plus, and here let us send the B character to see if we are able to write the EIP. So EIP, the size of the instruction pointer or the other frames are 4 characters or 4 bits. So we send it 4 times. Let me restart it again. Now let us execute this file. So go back to Windows. Now here we can see that our EIP is overwritten with 4242, that is the hexadecimal of B. So it means we have control over the EIP. Now we need to replace this value with jump ESP. To do that, we're going to use a module called Mona. So to use the Mona, we have to download this Mona Python file. That can be downloaded from the GitHub site. Once you download that file, you need to add it to the Immunity debugger. So you go to this program files, go to Immunity. In that there is a folder PyCommands. So here we can add the file mona.py. Once it is done, now we can use it to find the jump ESP. So first we need to find what are the modules are running by this process. So here we can see that we have given the command Mona modules, and here the list of modules. Now we need to find the module which have no security, that is all the values should be false, that is safe, SCH, ASLR, all values should be false. Now here we have this qt5core.dll. So we're going to see if this module is using jump ESP command, and we're going to use that address. So let us find it. To find that, we use Mona find command -s to search, and here we're going to use hex code of jump ESP, that is FFE4. So we write FFXE4 and -am. Here we give the module name, that is qt5core.dll. Now here we can see the result, and here we can see all these addresses can be used. All these addresses are represent the jump ESP command. So let us use this command, first one, the first address 688DD4ED. So we go back to Kali, and here we have to replace this with that. So we need to write that value in a reverse order. So first let me just write down here the value that we have found. The value was 88DD 4ED. Let me just check it. 688DD 4ED. Okay. Now we're going to write this in a reverse order because the x86 architecture uses the little endian format. So we're going to write it in this way. So this is how we write the address in a reverse order. Now let us add the shell code. To generate a shell code, we can use MSF Venom. So we use MSF Venom. So we have created a payload Windows shell reverse TCP to create a reverse connection from the target machine. Here we have given the attacker IP and the port 455 on which you want to listen. Here we created the F, that is a file option C, and architecture x86. Here we have given the bad character, that is x00. Bad character can cause the problem for the shell from executing. So we don't want to include this in the shell code. So this is our shell code. Let us copy it. Now we will add this in here. So before the shell code, we will also add some no ops. And we send the no ops, say 40. Now this is done. Let us create a listener. So now this port is open and we are listening on this port. Now we can execute our exploit. So before we execute this, let me just restart the application. Now let us execute it. So here we can see that we have got the connection. See, we got the connection to the target system. So let us write this command system info. So here we can see that. So here we can see that OS name Microsoft Windows 10. So we got the access into the target system. So that's how the buffer overflow can be used to exploit a target application and get the access to the target system. So that's all for today. Thank you.